Hi, welcome to our next level 1 tables, equations and graphs video. This is another linear function video and we're talking piecewise functions. Now piecewise function is simply a function over a specific domain of x values. Notice this graph here has been broken up into 3 sections. The first section, the second section and a third section. We call these pieces or different functions for each part of the graph. This is what we mean by a piecewise function. There's different parts to the graph. Right, let's get straight into example 1. We're going to develop a linear function for each section or piece of this graph. Now we've got 2 pieces. I've coloured one in blue and one in green. Let's start with the first piece. It's a straight line graph that passes through 2 on the y-axis and has a gradient of 1, rise of 1 and a run of 2. So a gradient of 1 over 2, which is a half. So we can say y is equal to m, which is a half, times x, plus c, which is 2. So y equals half x plus 2. But you can see that the section or that piece of the graph starts at 0 and goes all the way up to 7. So we need to tell somebody that it's only between 0 and 7 on the x-axis. Actually, see this open circle here? That means we don't quite get to 7, we stop just before 7. So what we're going to say is the x values for this section, this piece of the graph, they've got to be greater than or equal to 0 because we're starting at 0, but less than 7. We don't quite get to 7. Right, what about the other piece of the graph? Well, this is just a horizontal line that would pass through 7. So the equation of the graph is y equal to 7. But notice once again, we're starting at 7 for this piece and we're going everything above 7. So we're going to say the x values for this piece of the graph have to be greater than or equal to 7. Notice it's a coloured in circle, which means we do include the number 7 for the x value and everything above it. Right, let's move on to example 2. We're going to develop linear function for each piece or section of this graph. Here are the 2 pieces or sections of the graph. It's a distance time graph, distance on the y-axis, hours on the x-axis. Right, let's start off with the first section and we're going to work out the gradient of that blue section. So here we go. It rises up 200 squares and runs across 2 hours. So the gradient is 200 over 2, which has a gradient of 100. We know that the y-intercept is 0 because the graph starts at the origin. So here's the equation of that blue section. Y is equal to 100, which is the gradient, times x plus the y-intercept, which is 0. Now I'm going to replace the y and x with d and h because it's distance in hours. And remember, I don't need to go plus 0 for my y-intercept, so I'm just going to get rid of that plus 0. But we now need to tell somebody what x values in this section of the graph. And you can see that the graph goes between 0 all the way up to 2 hours. They're both coloured in circles, so they include 0 and 2. So we're going to say the number of hours is greater than or equal to 0 and less than or equal to 2. Right, let's move on to our second section of the graph, the green section, green piece. To work out the gradient, we need to work out 250 minus 200. It's a rise. And to work out the run, we go 6 minus 2. That's the run. So 250 minus 200 is 50, and 6 minus 2 is 4. So we get a gradient of 50 over 4, which is 12.5. So this has got a gradient of 12.5. So let's go up here and work with that because what we don't know is the y-intercept. We can't read it off the graph and we're not going to guess. So to work it out, we're going to pick one of these 2 points that the graph does pass through. Doesn't matter which one you pick. I'm going to pick 6 hours and 250 kilometers, and I'm going to use that. So I'm going to substitute 250 in for y and 6 in for x, and I'm going to get 250 equal to 12.5 times 6 plus c. So 12.5 times 6 is 75. So now if I subtract 75 off the 250, I've worked out that c is equal to 175. I know my y-intercept is 175. So I can write down my formula, y equal to 12.5x plus 175. I'm just going to change the y's and x's over to d's and h's. And once again, I must tell somebody that this section of the graph occurs between greater than or equal to 2 and less than or equal to 6. Thanks for watching.